Hello everyone. The topic for this project is online voting using blockchain. So this is the outline of what I'll be covering today. You can pause and read if you want. So what is blockchain? So before I explain what blockchain is, I will need you to make you understand what is the requirements of having a blockchain or running a blockchain for that matter. So first of all, we need a network of computers, which is basically a decentralized network, and this network keeps a shared ledger. And what this ledger is you can say that the ledger itself is a blockchain. However, a more accurate definition of this ledger would be a shared database of all the transactions which are done. So now your question will be, what are the transactions? So if I want to explain it in terms of what my project does, a transaction is basically a vote that I have voted to party A, you have voted to party B. This information is the transaction. If you're talking about using blockchain for online payment, then someone paying a, a person A paying to person B X amount is also called a transaction. So any kind of information which we want to store is called a transaction. And these transactions are stored in blocks, which are then mined by certain computers, which we'll get into later. And then after mining, they are stored in sort of a linked list. That is essentially a blockchain. The blocks are linked to their parents and their children using the hash of their identities. And this creates a single linked list of blocks, which is known as blockchain. And this blockchain basically was is used in cryptocurrencies like Bitcoin. And actually, Bitcoin was one of the first technologies to mainstream the use of blockchain. Now, coming to how does my blockchain work? That is, I will explain this in terms of my current project, which is the voting system. So first of all, a transaction is initiated. That is, someone votes. A voter votes to someone, and that is called a transaction. It is initiated. After that, using some mathematical algorithms, which we will see later, this is verified once, and then it is stored on the local device. Now, after number of transactions are stored in the single block, that a block is created. So to explain it more clearly, if let's suppose there is already a block which stores some transactions, then we append this transaction in that block. And if there is no such block, we create a block and then add transactions to that block. Then the block is verified again, like the transactions in this block are valid transactions or not. Then we use consensus mechanism, which is a mathematical algorithm, which basically states that majority of the nodes in the network, that is, majority of the computers in this network, should agree that yes, these transactions are good. No tampering is done with these transactions. And after this consensus is reached, these blocks are added to the chain. Now, after the block is added to the chain, the transaction is verified once again, and then the ledger, the nodes of the network, copy and replicate this information from the ledger. And as a result, the whole system is the whole thing is decentralized. No single authority has power over it. And people people can have their computer as the node. Like, I can have my computer as the node, you can have your computer as the node, even your teacher can have your their computer as a node. So no one has access over the sole, no one has the sole authority over the data, and as a result, no fraud or tampering can be done. So there are certain characteristics of the blockchain. The first is decentralization, which I said earlier. Like, there is no middleman, there is no central authority. As a result, the chances of fraud is less. So to get my point across in a better way, I need to tell you about a recent incident that is in America during the last elections when Joe Biden won against Donald Trump. The people who were in support of Donald Trump were furious, and they were saying that the elections are rigged. The Joe Biden has done some sort of fraud or corruption, and as a result, the elections are won by Joe Biden and not Donald Trump. They even attacked the White House. They caused riots there, which led to certain issues for the national security. So if the data is decentralized, and which brings me to my next point, the data is transparent and everyone has access to all the data. Like they are sure that yes, this number of votes is what the election commission is showing, that yes, this person has won by this many votes. Then that will lead to less distrust, and people will agree to the votes, the results of the election, and create less ruckus. The next point is security. So we use uh, very secure cryptography, encryption systems, that hashing algorithm, which makes sure that the transactions are hashed, and they cannot be tampered with. Also, we make sure to encrypt the identity of the voter, so that no one can know who voted for who, and we only have a count of how many votes a certain party does have. And as a result, the security is not a major concern. uh, Now brings me to my next point, efficiency. So since people can vote from anywhere, like they can vote from their home, they just need to click a button that vote this party. The transactions are very fast. The data is verified multiple times and stored in the ledger. It is counted, and results are also instantaneous. This negates the need of any middleman, and this saves a lot of money, and does the things very fast. Also, the next point is a very, very important characteristic of blockchain, that is sorry, I'm extremely sorry, that is immutable data. So what it means is that once the data is added to a blockchain, we cannot tamper with the data, and we cannot change it. So for that reason, first we need to understand that why the data is secure. So since the ledger is shared between all the nodes, people need to, if someone wants to attack and do some fraud or some corruption, they need to change the information in the ledgers across all the devices, not all the devices, the majority of the devices. That is the 51% attack. So let's suppose that there are 10 computers. They need to change the data in at least 6 of the computers at the same time to, actually have an effect on the results. Even when we are talking about 10 computers, it is almost impossible to do so, because doing it at the same time is not very feasible. But when you are actually talking about the nationwide elections which are conducted, we come to the point that, like, there will be thousands, maybe there will be lakhs of computers which are as a part of the network. So if I'm saying a very low number right now, that let's suppose that there are 5 lakh computers in a network, which are the which consists of the blockchain, which creates the blockchain. This So a person who wants to attack, who wants to do any malpractice, will need to change more data in more than 2.5 lakh computers, which is not really feasible. Also, like, I just don't need to change the transaction at one place. When I change the data in the transaction, it messes with the hash ID of the current block. So, and which I'll come into later, the structure of the blockchain. So there are multiple blocks, and each block, the data in each block contributes to a certain hash. Using this hash, we create a parent hash for its child block. So let's suppose that there are 5 blocks in the node, in the chain, sorry, and block two's hash will be a parent hash for block three. Similarly, block three's hash will be a hash for with the parent hash for block four. So if I want to change something in block two, this will change the hash of block two. As a result, it will change the parent hash of block three, which will in fact change the hash of block three. And as a result, all the blocks which come after block 2 will have an effect, and it will be very difficult to change data across all these nodes, across majority of the computers at the same time. So the data is immutable, the security is not a concern, and it is a very safe system. Now, like what I was saying earlier, the structure of each block. So the block stores data. That is who voted to who. As we can see that the person X voted for party A and their voter ID is stored. Again, just to remind you, this voter ID is not stored in the standard format. The voter ID is in fact encrypted using strong encryption uh, technologies such as SHA-256, and the whole data and the block ID itself is used to create a hash of the block, which can be seen on the right side of the screen. Now, using this hash, we create a parent hash for its child block, and as we can see, the hash of previous block, which is on the bottom left of the corner, is in fact the hash of its the parent of the current block, and so it creates a chain which is called the blockchain in itself. Now, the structure and features which I've already explained, you can pause and have a look if you want. Now, proof of work. So, I mentioned earlier regarding the consensus algorithm. So, when you know, so what is actually being done to make sure that the data is verified? So, for that, whenever we mine the data, or whenever the admin tries to see the full chain, they try to see the full blockchain. At that time, the proof of work mechanism is implemented. So what does this actually do? So at each and every point I mentioned earlier, all the nodes across the network verify each and every transaction in each and every block. So all the data is verified once, and when everyone agrees, that 51% people agree that yes, the data is good, that there is no sort of malpractice being done, and at that moment we come to the conclusion that yes, the consensus is achieved and the data is good and verified. So this proof of work mechanism is the consensus algorithm, the mechanism which is used to make sure that everything is in order. Now, some common terms which I explained earlier, which I'm just reiterating right now: the nodes, the transactions, the blocks. These blocks make up a chain. Now, one thing I have not mentioned earlier are the miners. So, miners are basically special nodes who have privileges, or I should say, actually not privileges, but the duty of making sure that the transactions are valid, and these transactions are added to the blockchain correctly. Like the even while adding to the blockchain, nothing is being tampered with them. Now, this so why do we actually need this system? Like, what is the current problems being faced by the classical voting system, if you want to call that? So there are several security risks. There are chances of riots. There are chances of identity theft. There are chances of vote tampering. uh, uh, then we come that, like, if let's say there are long queues, I have to wait for a whole day just to cast a vote, which is not really possible in current lifestyle. Then there are security breaches, data leakage. All of this also requires a lot of logistics, a lot of paperwork is required, which makes it very time consuming. But also, it is also challenging for voters with disabilities to even get to the polls and vote. Uh, Overall, this process is very tedious and expensive. So why do we need to do this when we have such a brilliant technology at our disposal? So which brings me to my next point, like why use blockchain? So the above mentioned points, the previous mentioned points of the problems, current existing problems with the voting system, along with the advantages of blockchain, are in itself a very good and valid argument of why we should use this blockchain based online system instead of the classical voting system. However, so before I come to some drawbacks of the system, I would like to share this beautiful demonstration of what is actually being done in this blockchain based system. The source of this picture is Geeks for Geeks. So first, when a voter casts their vote, which can be done from anywhere, they just need valid credentials. They should be an eligible voter to cast their vote. After that, this is stored in a transaction. The transaction ID, who voted to who, the timestamp, everything is stored. When we create a hash of the voting system, and then this system is stored on the local network, local node of the network. Then it is verified. After verifying, this is added to a block. The block is mined. The mined block is shared across all the different nodes of the network. Each and every node verifies the data once more, and then finally the block is added to the chain. Now, after adding to the chain, we can instantaneously see the result as a see the result. So the process is very smooth, very fast, and very elegant. Now there are certain challenges. There are not drawbacks, but there are certain challenges we need to face if we want to implement a nationwide online voting system. The first is eligibility. So to make sure that every eligible candidate receives a proper credential for the system, to make sure that you know everyone gets a chance to vote, we need a lot of support from the government. We need access to database of all the eligible voters, their private information, like the where to send the credentials, their email ID, their phone number. Some sort of help from the government is required, which brings me to my next point, that is the privacy. So since like people will have access to the data, like since this is a decentralized system, everyone will have access to all the data available. This will lead to certain complications that let's suppose that I do not want to disclose who I voted for. That is, I don't want to disclose if I voted for BJP or for Congress. And people have access to my voter ID. They can clearly see that the voter ID, this voter ID voted for this party. This may lead to some fights, even some riots. However, this can be, solved easily with the use of encryption. That is, we can, while storing the transaction in the node, in the block, we can encrypt the private information of the voter using very secure encryption methods such as SHA-256. So, like, the privacy is maintained. Reusability. So, again, to make sure that multiple votes are not casted, I need to like the system needs to make sure that it needs to maintain a database to see whether the voter has voted once or not. Otherwise, people might vote multiple times. This is a valid argument. Like, this is a valid challenge to face, that we need to maintain a database of, like, if you're talking about India, there are more than a billion people on the country. So making having a database, such a large database, updating it regularly is a difficult task. So yes, there are certain challenges, but it can be done easily. The next is fairness. So since everyone has access to the data, they might also have access to some sort of decryption key to you know validate or check the data. This may lead to some people trying to change certain things in the, trying to do frauds in the system. However, this is not very easy. As I explained earlier, people will need to change the whole, basically change the whole chain throughout 51% of the computers, at least 51% of the computers, which might lead to a lot of problems. Like, it is not really a possibility for them to do so. It is almost next to impossible. They need quantum computers to do that. So I will not go into detail of the proposed architecture. You can pause and look, because it is not something which I think is needed to be discussed right now. Uh, you can just pause all these pages and make sure you are clear with everything. Now, this is again the 51% attack, which I mentioned earlier, that people need to, since the consensus is 51%, that if 51% of the people agree that certain thing is right, in order to change certain data in the ledger, you need to change it across at least 51% of the computers. And even if you change it in exactly 51% of the computers, people will notice, yes, this looks fishy, and they might look into it in more detail, and it will lead to the malpractices being, quickly get noticed, and it won't be possible for them to do so. These are the references which we have taken, Geeks for Geeks and ResearchGate for certain images. And the last is the a paper which we referred to while working on this project. These are my team members which have contributed wonderfully for this project. Now I will like to show you the implementation part of my project. So this is the home page, which will be accessible to everyone. Like the home page, like voters can vote and miners can mine. And this will be the admin page. So not everyone will have access to this page. This will be a secure page on a secure server, and only the admin will be able to administration side will be able to access this page. And even so, they will need certain credentials. Now, when coming to this, so let's suppose that I want to mine the data. So when I click on mine, my computer first needs to be a verified miner. And when it is a verified miner, I need certain credentials. So I need a miner ID and I need a password. We have not yet implemented the password part of this website because it is trivial thing. We wanted to focus more on the blockchain part of it, and so we have just implemented a confirm. We have to write confirm here, and when I log in, we can see that the currently there are no transactions because no one has voted. Now, when you see that the index is 2, you might ask that why is index 2 when the everything like the index should start from 1. That is because if you remember the the proof of work mechanism, when I explained it, there is a Genesis block, which is basically the head of the linked list. So, like, no transaction is stored in this, but just to create a hash for its children, like the parent hash for the first node, we need a head block, an indicator of starting of the chain, and that is basically a Genesis block. And we can, when we see the full chain, I will make sure to point out that the Genesis block was there, and we can see that this block is no transaction and it is at index 2. Now, when I mine when I vote, so again, I need certain credentials for it. So this is voter ID. Let's suppose I'm voting with voter ID 1. Again, this is the password field, which we have not implemented because it was trivial. We have had confirm instead of password. When I vote, we get to a next page. So I'm sorry if it is taking some time to load. I'm hosting it on my local PC and not on a website. However, I will link I will have a link in the description to as a proper working website which will help with uh, which you can basically use and try it out. So I don't know why this is taking so much time. Let me reload. Yeah, so I don't know why it was taking so much time. Again, so this will bring me to the list of all parties participating in the election, and I can vote anyone. Let's suppose I vote Nota and I submit. It will give me that yes, good, voter by this ID added successfully. Check your email for details. Uh, Now this clicking OK brings me to homepage again. And now when I mine again, we can using proper credentials. So we will see that yes, so party A. So this is the voter ID which is hashed using very strong encryption algorithms, has voted to party B, which is Nota, and there is one vote, which you can see that is at index 3. Just to remind you again, index 1 is the Genesis block, index 2 is the empty block which was mined, and index 3 is this current block. Now, let's suppose that I want to vote again. Now, one major thing we saw that the reusability of the votes, that people do, we need to make sure that people do not vote multiple times. So, let's suppose that I try to vote again with voter ID 1. It will give me an error that vote can be registered with voter ID this because you already voted once. So I will retry. Now again, like there are three possibilities. Let's suppose that a voter ID does not exist. So sorry, I'm extremely sorry. So let's suppose that yeah, I know for a fact that this voter ID does not exist in my database. So I will try to vote with this. It will give me an error that this voter ID does not exist. So yes, this the other case is that the voter has already voted, which I showed earlier, and the other case is that the voter ID has not yet voted, so we can vote with them, and which I will just show some more times, and we can see that even adding multiple votes by different people does not affect the system in any way. See, and now when I mine the mine the data, again I will need valid credentials. If I suppose want to mine with a miner which does not exist yet, it will give me error that this miner does not exist. So I will need valid credentials for voting as well as mining. And when I mine with valid credentials, I can see that in a single block there were two transactions made. So all the transactions which happen between mining are stored in a single block. And this are the two transactions. One voted for BJP and one voted for Nota. So yes, this was the homepage side of thing. Now coming to the admin side of thing, there are two possibilities. There are two functionalities which were implemented. First is to see the full chain, that is, who has voted to who. To see that this is the whole chain. The first is the Genesis block. Like it does not have a previous hash. It has a current hash, which is used to generate a previous hash for its children block, and it does not store any transactions. If you remember that I just mined an empty block, so it showed that there are no transactions here. This actually can be argumented that you know uh, people can mine multiple times just to clog up the system, or just take up storage space. However, this is not really a feasible attack on the system, because every second hundreds and maybe thousands of voters are casting their vote. So if I'm mining something and instantly someone else mines on their computer, even in this between this instantaneous mining, there would be hundreds of votes. So it won't be an issue. The system won't be clogged up, and it won't be an attack. After that, this we can see that this was the voter ID 1 voted once, and voter ID 2 and 5 voted twice. Now, coming back to the another functionality of the admin side, which is they can add new voters. So if you remember, voter ID 10 could not vote earlier because it did not exist. Now let's suppose that I am, adding that voter to the system. Then we can see that yes, voter ID 10 added successfully. So if I come back and vote again, then sorry, this is not the correct ID. Yeah, this. So if I vote again, then yes, I can vote now, because the because the voter has been added successfully to the database. Now, if I try to if I come back here to the admin page again, I can now see that if I try to see the chain, we can see that the vote by voter ID 10 is not added to the chain because I have not yet mined the data. So in order for the votes to be be seen in the chain by the admin, it needs to be mined. So let me mine once, and if I mine it correctly, we can see that this voter has voted to Nota. And if I see the full chain again, I can see clearly that the last index 5 vote has been added successfully. So this was the implementation of our project, and thank you for your time. So please feel free to add to like and comment on this video. Feel free to give any feedback you want, and thank you.